So for the last instruction day of Chapter 8, we're going to go back to talking about the law of signs and talk about what we call the ambiguous case for the law of signs. And what the ambiguous case means is when you're solving for a triangle, for an angle, there could be possibly 1, 2, or 0 triangles that can be formed with the given information. And the ambiguous case only happens when we have SSA, meaning we have two sides and an angle that is not between the two sides. So the notes today, we will walk through an example where we have only one possible triangle that can be formed, which is similar to what the problems were looking like in day 2, but also a situation where we could have 2 possible triangles that can be formed or 0 triangles that can be formed. So taking a look at example 1, the first thing I like to do for these problems is draw a triangle and label the information that I have. So if you look here, and this triangle is not going to be to scale necessarily because I don't really know what the other angles are, but if I label the triangle here, what we have is SSA. We have side A and side B, and angle A, which is not between the two sides. So I will have to check if there's more than one triangle that can be formed. So here's how you do that. You would set up the law of signs like you normally would, and if you look at the triangle we have, the only piece of information we can find right now with the law of signs is angle B, because we have the side opposite. So if I set up my law of signs, I would have sine of 32 over 17 equals sine of B over 11. And then I'm going to solve for angle B. So I'd multiply both sides by 11. So I'd have sine of B equals 11 sine of 32 over 17. And then to find angle B, I would take the inverse sine of 11 sine of 32 over 17. And what I would get is 20.053 degrees. So that's angle B. Now when I say there could be more than one triangle formed, what it really means is right here, we could possibly have more than one answer for angle B. So what I'm going to do is make a chart here for the triangle I have. So angle A, angle B, angle C, side A, side B, side C, and label basically everything that I have. You don't have to make the chart. I just think it's really nice to organize all your information and helps you keep straight how you're going to be checking this second case. So what I mean is, if you think back to our unit circle stuff, what we talked about is there's really 2 angles that have the same sine value or the same cosine value. So if you think about it, 20.053, another angle that has the same sine value would be 159.947. And the way I found that is if I took 180 degrees and subtracted 20.053, I would get 159.947. So 159, if you think about where its location is, that would be in quadrant 2, if I'm putting myself on the unit circle. And that angle in quadrant 2 has the same sine value as 20.053, which is in quadrant 1. So when we have a triangle that's SSA, we have to consider more than one possibility. So I just put that 159.947 could be a possibility for angle B, since they do have the same sine value. Now here's how you decide whether it makes sense or not. I'm going to try and sketch a second triangle with the information that I just found. So if I put 159.947 in for angle B, what I have to decide is, does this make sense in the triangle, or can this triangle be drawn? And if I think about it, the way you check is if I add 159.947, which is the angle I just found, to my original angle 32, it would be more than 180, which means angle C couldn't be drawn, or angle C would have to be negative, which means in this problem, I really only have one possible triangle that can be formed. So what I do with this information is I essentially cross out the second triangle and cross out the second angle for B. So now that I know that B can only be 20.053, I would carry on solving this triangle the way I have been. I'm going to finish it with law of signs, but first I'm going to find angle C by subtracting 32 and 20.053 from 180. So if I do that, what I would get for angle C is 127.947 degrees. So I found angle C, and then I'm going to find side C using the law of signs again. So my setup would be sine of 32 over 17 equals sine of 127.947 over C. And you could use the information for B, right? You could set up the law of signs using B, but I typically use the given information. That way I'm not trying to operate with my angle that I found, just in case if I was off by a few decimal places or I typed it in my calculator wrong, I could still possibly get my information for C correct. So solving for C, multiply both sides by 17 and C. So I get C sine of 32 equals 17 sine of 127.947. Divide both sides by sine of 32. And make sure you are careful when you type this in your calculator. And what I would get for C is 25.298. So this first example here, using the law of sines just like day 2, but I do have to consider that there could be a second triangle that works. And in this case there wasn't, but that second triangle I drew in that check is really what we're going to be doing every time we have SSA in our given information. So for example 2, I'm going to solve the triangle again. First thing I'm going to do is draw it. So if I draw my triangle here, label what I have, take a look at it. This is again SSA. I have two sides and an angle that's not in between there, so what I have to do is I'm going to check to see if there's more than one possibility for solving this triangle. I could have, an ambiguous case in this problem could happen, so I would have to check more than one possibility. So I would set up the law of sines to find angle B, because it's opposite of side B, or opposite the 7. So I'd get sine of 30 over 6 equals sine of B over 7. And then I would multiply both sides by 7 to get sine of B by itself. So I'd have 7 sine of 30 over 6. And then to solve for angle B, I would take the inverse sine of 7 sine of 30 over 6. And what I would get for angle B is 35.685 degrees. So there, I have angle B. So what I can do now, again, is make a chart for this triangle that I drew first and label everything that I have. So A is 30. Side A is 6, side B is 7, and then I just found angle B to be 35.685. But I do want to check, because this is SSA, I could have a potential second triangle, if the supplement of 35.685 also works. So I would subtract 180 minus 35.685, and I'd get 144.315. And I got to check if this could possibly work. So what I'm trying to draw is a second triangle and fill in 144 for angle B, and see if this works. So if I put 144.315, and what I mean by works is if that angle I found 144.315 and my original angle 30 are less than 180, then that means angle C could be an angle, could be a number, and I could have a second triangle here. So in this case, 144 plus 30 is 174.315. So angle C actually can be calculated. There's a little bit left over to get to 180. So I do actually have two triangles. So what I would do in this case is I would make a second chart for my second triangle so I can keep all my information straight. Again, you don't have to do that, but it's a good idea to kind of keep your information straight. So angle B is 144.315. That's what I found. And then I can find angle C for both triangles and then finish solving each triangle independently. So I'm going to go back to my original triangle and finish it. So find angle C, 180 minus 30 minus 35.685, and I'd get 114.315. And then to find side C, I would use the law of sines, setting it up so that I can find side C. So I'd have sine of 30 over 6 equals sine of 114.385 over C. Multiply both sides by 6 and C, or cross multiply is how you'd probably handle that. Then I would divide both sides by sine of 30 to get C by itself. And I'd get C is equal to 10.936. So that's finishing that first triangle. Found all the missing information, and then I'll go to my second triangle because there is a second case here and finish solving that. So I'd find angle C first. So 180 minus 30 minus 144, which should be a pretty small angle. There's only a little bit left to get to 180, which in this case is 5.685. So I found angle C, and then to find side C, I would use the law of sines again to find side C. So I'd have sine of 30 over 6 equals sine of 5.685 over C. Cross multiply or multiply both sides by 6C. I'd get C sine of 30 equals 6 sine of 5.685. Divide both sides by sine of 30. And what you should get for side C is something very small, 1.189. So in this problem, example 2, I had two triangles that both satisfied my original information, and that's why this is called the ambiguous case. So in example 1, we looked at a side-side angle case where we only had one possible triangle. In example 2, we looked at a side-side angle case for the law of sines that had two possible triangles. So for the third example, we're going to look at a situation where we could potentially have no possible triangles. And the idea there is this. Just because we say that a triangle has specific properties doesn't necessarily mean that a triangle can be drawn with that information. So if we look here, I would take the triangle information I have and label it. So angle B is 88 degrees, side C is 62, side B is 14. And I would look at this. This is SSA as well. So I will have to check if there's more than one possible answer or no possible answers. So I would set up the law of sines in the triangle. So sine of 88 is equal to sine of 88 over 14 is equal to sine of C over 62. And I'm going to solve for angle C. So I would multiply both sides by 62. And I'll get 62 sine of 88 over 14 equals sine of C. And then to find angle C, you would take the inverse sine of 62 sine of 88 over 14. And what should happen is you should get an error. Okay, it'll say domain error in your calculator, which essentially means there's no possible angle for C that has that value. And let me just illuminate that issue here. So if I kind of work over there, 62 sine of 88 over 14 is 4.42587 something something something. And the idea there is sine of some angle needs to give me the value 4.42587, which will never happen, because if you remember when we were talking about sine or graphing sine, the values of sine will only ever be between 1 and negative 1, which means sine of C will never reach the value 4.425, which means angle C is undefined. So if you think about the concept here, there is no angle C that would, in this triangle, that would give me an opposite side of 62, where the opposite side of B is 14. That's just one side is way too big or way too small, and the triangle can't be drawn here. So how do you answer this? So provided you typed everything in your calculator correctly and the error message makes sense, it's not that you just made a mistake in typing it in. Say I assume we typed it all in correctly and get an error message. There's really two ways to answer this. One is there's no possible triangle, or you could say there's no solution. Either way, we can't continue solving information in this triangle because we are missing the ability to do so in this side-side angle case.